In this video we'll talk about deep learning, since we described machine learning algorithms and in particular artificial neural networks in the last video, and you will see what deep actually means. We'll take this image, okay, from this book here, Deep Learning with Python, from Scholle and Watson. And deep learning, it's when we have several layers, okay, in a neural network, but these layers are able to unveil features by themselves. Okay, let's see a little bit more about this here. In the last video, we talked about artificial neural networks, where we have, for example, these multiple layers. But having multiple layers by themselves doesn't mean that we have an automatically we are learning automatically the features. These multiple layers, we might have several features calculated by us, okay, in tabular data, and the multiple layers are not learning the features by themselves. And in that case, it's not deep learning. It's deep can be considered deep artificial neural networks, but still machine learning and not really deep learning. Okay, it's not just because we have a lot of layers in a neural network that we have deep learning. We have to have this automatic learning of features. We asked several chatbots, large language models, what is deep learning in ChatGPT? Deep learning is a type of machine learning that uses neural networks with many layers to learn complex patterns, but key here, directly from the data. And it compares. Traditional machine learning, we have the data, we have the chosen features. I wouldn't say manually because many fields have an automatically calculation of features and selection of features. Okay. Then we have machine learning models, and then we make predictions. In deep learning, we have the raw or less processed data. We still have to process the data, for sure, but we don't have to calculate the features. That's what it means, really. And here we have this step of calculating the features. And then we have deep neural networks learns the useful features by itself. This is the part that deep learning does. And then it makes the predictions. So it's not only having layers in the neural network, but having layers that learn the features by themselves. So the deep simply refers to having multiple layers of learning transformations. I must actually say that ChatGPT did a very good job for this question, okay? Very good. If we go to Claude with Opus 5, with high intensity, it says it's still correct, but not the same so clear explanation as ChatGPT. We have deep learning is a branch of machine learning that uses neural networks with many stacked layers to learn patterns, also key here, directly from raw data. The core idea is learning representations. Traditional machine learning is often required for humans to engineer the features a model should pay attention to, and deep learning skips that. Okay, and it's it. Okay, that's it. If we go to Perplexity and read the first line, deep learning is a subset of machine learning based on artificial neural networks with multiple layers. It kind of doesn't say that, but if we learn it says that we just need the multiple layers. But no, if we go here, we see learns patterns directly without manual feature engineering. Okay, that's correct. Here, if you say that the term deep refers to networks having multiple hidden layers, so we are less convinced, but here then it explains the right way. If we go to Google, it says that deep learning is a subset of machine learning that uses multi-layered artificial neural networks to mimic the human brain. This is discussable, but let's go forward, and automatically learn patterns from large amounts of data. This automatically, it's not really directly from the data. I prefer the words directly from the data because the automatically we can also employ feature engineering, feature calculation, feature selection, which is typical of machine learning and not deep learning, and do that automatically for many fields. Okay. If we go to Wikipedia, written by humans, we see in machine learning, deep learning focuses on utilizing multi-layered neural networks to perform tasks such as classification, regression, and representation learning. Doesn't say anything about directly learning the features with deep learning without feature engineering. Okay. The adjective deep refers to the use of multiple layers in the network. Okay, so not really what we want, from 3 to several hundred or thousands. But if we look at the image, then we understand this idea. It's a bit confused, but it kind of, you get this idea. If we have an elephant in deep learning, it learns these representations, these features, which together form the elephant. Okay, and we see by these features that is different from a kangaroo and different from a penguin. If we go to the deep learning book, which we talked about, and I took the image itself, and just to make the publicity, you can go and buy the book or just see the book here, read online for free. So, deep learning is beginning in the original with the original data, the input, having multiple layers, reaching the output, but not only any type of layer, but layers that learn the representations of the data, of the pixels of the data. Okay, directly from the data and also automatically. This is deep learning. Not only having many layers, but also many layers that learn features by themselves without you having to do feature engineering, feature calculation, and feature selection. That is deep learning. So, now that we saw what deep learning is, let's continue. Here we have a work that in the same, this is an example from a work, not from them, but a review in Nature from Hinton, which is now a Nobel Prize, and LeCun, which I think, I don't know if he was a student from Hinton, but it's very important in the field. Many articles for deep learning are from him. He worked for Meta, for Facebook, for many years. Okay, using artificial intelligence to identify images of you and your dog, and now he has his own company. Okay, so also a very big name in the field, and Benji. And we have two typical deep learning architectures. CNNs and RNNs, we will see what they do. And they do different things. On the same work, they do different things. The captions, the written part, they are generated by recurrent neural networks. Okay? And these captions take as input the representation of the images by deep convolution neural networks. Okay? So deep convolution neural networks identify these main characteristics of the images. Here a frisbee, here a dog, and then here a stop signal, and then recurrent neural networks go and generate the caption itself, taking into account these features obtained from deep convolutional neural network. So everything automatic and directly from the raw data. So, but this just to explain in simple terms from an example that CNNs, deep convolution neural networks, they are useful for images, videos, speech and audio, whereas RNNs, they are useful for sequential data such as text and speech. Is deep learning all you need? Okay, we thought we learned about machine learning, feature selection, feature engineering, and now we don't need it. No, we still need deep learning, and we will see. We still need machine learning. Here we have several methods. XGBoost, a traditional machine learning method, traditional but very good, okay. Random forests in Kaggle competitions, like I think 10 years ago, more than 10 years, like, was the chosen method. It beat everything, but then it came XGBoost, and it was very good for tabular data. This is a test for tabular numerical data, which means like Excel type of data. And XGBoost, very low error. If you take deep learning, these methods are deep learning, and the errors are much larger, okay? Then you have simple ensemble. Simple ensemble, it probably means an ensemble of several XGBoost models, okay? And it improves a little bit the result. If you use deep ensemble, which means using several deep learning methods without XGBoost, the error is still high. But if you use a deep ensemble, an ensemble of deep learning methods together with XGBoost, you will have the best result. Okay, so is deep learning all you need? No, you still need machine learning to obtain these results. Traditional machine learning, this is decision trees based ensemble methods with boosting. Okay, we saw in the last video what that was. We still need deep learning. We still need machine learning, but it's machine learning, traditional machine learning with deep learning that outperforms everything. So we need both of them. Okay. The message is for tabular numerical data, deep learning is not all you need. And highlights from this study, deep neural networks are not good for all types of tabular data. XGBoost actually can perform deep learning models on tabular data. And pay attention to this, it's harder to optimize in terms of architectures and parameters the deep neural networks in comparison with XGBoost. Okay, and especially not only because deep neural networks you can have like infinite architectures, okay, combinations of layers and nodes, but also the computational cost as you increase the size it's much larger than XGBoost. It can be 100 times larger, and this is important. Okay, let's continue with this question. Is deep learning all you need? Here we have another study where we have, these are two deep learning methods, and we have here more, and this is traditional. Oh, I'm selling traditional, but these are very good methods. LightGBM, CatBoost and XGBoost, they are decision trees ensemble methods, okay, and they still have a very high performance. Just to make sure here, higher elo means stronger performance across these benchmark tasks. This is the result for the final, for several benchmarks. This is the benchmark of benchmarks, let's say it like this, for several data sets and benchmarks. This is like in chess, okay? The higher the value, the better the method. and let's see some conclusions. CatBoost, okay, before we go, the default is when you use the method without any hyperparameter optimization, okay. In orange, it's after you do hyperparameter optimization, you tune the model with hyperparameter optimization. The tuned plus ensemble, it means that you have an ensemble of several models, not only the best model with the best parameters, but also the other ones that didn't perform as higher. And actually, you will see that when you do this ensemble for each method, it actually improves the results. And let's see the conclusions. CatBoost, a gradient boosting decision tree, has the longest blue bar, followed by a deep learning method, and then possibly another one. Okay. It's the best out of the box performance with no tuning at all, no hyperparameter tuning. So if you want only one line of code, no hyperparameter optimization, that's the peak CatBoost. And I say that in fields that you already have the features, it helps a lot not having to do hyperparameter optimization computational and in terms of your time. RealMLP and TabM, they are neural networks, multi-layer perceptron neural networks, so not very complex. Probably you don't use it with scikit-learn, but it's the type of neural networks that you can obtain with scikit-learn, okay? But you don't use it. It's not available in scikit-learn, okay? I think. TabM includes internal ensemble, so already encodes the ensemble part that we will see that we already saw that, or we can infer that improves the results. Only overtake CatBoost after tuning an ensemble. When you compare these deep learning methods, when you do hyperparameter tuning, it still doesn't improve upon CatBoost, but after you do tuning and ensemble, then it beats CatBoost. But also very near and within standard error, equal results to LightGBM, which is also um, a decision trees ensemble method. But pay attention with much higher inference costs. So the cost can be of using multiple learning can be 15 to 100 times higher than CatBoost. But this debate, it's a false debate of machine learning versus deep learning because both families feed across model ensemble. This purple line, it's the mixture of several of these deep learning and machine learning models that beat everything. Okay, so is deep learning all you need? No, you still need machine learning, and both of them, at least now, and both of them together, it's the thing that beats everything. Okay, so many of the things that we are learning, they are very, very useful for any type of machine learning, deep learning. Final lesson, final message. Every model has its place. Linear regression and decision trees that we saw in the last video have very high explainability, which is important. Tree-based ensemble methods like CatBoost and XGBoost, they are a good choice for tabular numerical data, Excel type of data. And deep learning with neural networks is revolutionizing the world in terms of language, computer vision, speech, and audio processing. This is the final message, okay? If you have a doubt, leave us a comment, and let's go to the next video.